An industrial robot is made up of 6 or more axis joints connected in series. This provides a kinematic chain from the base of the robot through to the active tool mounted on the end effector. Within these joints there are motors, gears, reducers and encoders, which record how much the axis has rotated by. A joint offset is a deviation from the default 0 position of the joint to its actual position. Updating these offsets is important for each of the axes to move correctly with respect to each other. If these are not set correctly, the robot will not be able to achieve a path performance it is otherwise mechanically capable of delivering. After an incorrect TCP setup, the next greatest contribution to robot error are incorrect joint offsets. Practically, this means a request to drive a straight line results in a curve. To correct this, more programming is required to split the line into shorter pieces which can be successfully controlled. In certain high accuracy applications, if the joint offsets are not set correctly, the robot can fail to meet the required standard. Currently, the method to update joint offsets, or remaster the robot, requires the user to line the external casing witness marks up by eye, or attach a robot model specific jig to bring the robot back to its factory default. There are many reasons why joint offsets could be lost, but the most common are due to collision, loss of backup battery power, or during repair. The RCS T-90 takes the pain out of doing this, with an easy to follow process allowing you to remaster the robot to its true position in less than 30 minutes. Ideally, the robot should be set to its true 0 position when it is first installed, so its initial state can be returned to at any point thereafter, and the robot can perform to the best of its mechanical capability. However, there are cases where this hasn't occurred. A robot is already in operation, but later needs to be repaired. In this situation, you'd want to return the robot to its previous working state, even if it's imperfect. Otherwise, the entire cell would need to be completely reprogrammed. To achieve this, you need to baseline the robot before the repair using the RCS T-90, then make the repair, before recovering it to its previous baseline state. Once again, the RCS T-90 provides a fast and straightforward method to achieve this.